morning to all. First two chapters already you have written exam. Have you written well, students? Okay. Now, third lesson we have learned about pressure, thrust, we have learned, and two formula also we have learned. P equal to F divided by A. What is F? Force F, and A means area of cross section. P pressure. Another one formula we have learned. P equal to H rho G. What is H? Depth. Then rho density, G acceleration due to gravity. By using these two formula, problem there means suppose force and area of cross section given means we have to use this formula P equal to F divided by A. Suppose that the height given, density given means we have to use this formula P equal to H rho G. This problem number 1 and 2. Example problem 1 and 2 already I told. So just substitute and write the answer and unit. What is the unit of pressure? Pascal is the unit of pressure. So we have to write the unit also. Now we can learn about this Pascal's law. So the unit of pressure is Pascal. Why the unit Pascal came? So the scientist name Blaise Pascal. Like that here, this Pascal law also demonstrated a Blaise Pascal. So this law is called Pascal's law. This Pascal's law, by using a glass jar, the Pascal's laws are demonstrated. Now listen here, this consists of, is made up of glass and full of liquid. You want to pour full of liquid. This glass jar full of liquid. And this glass jar closed with the piston, airtight piston. This glass jar closed with the airtight piston. So inside the glass jar, the liquid is there. So inside the glass jar, liquid, and this glass jar is closed with the piston. Now just listen, inside the liquid is there. No, inside this glass jar liquid is there. Some exerted some pressure. Now this glass jar has hole in all direction. See, at the bottom of the glass jar there is a hole in all direction. Now what happened when we give some external pressure on the piston? If we are giving some external pressure on the piston, so what happened? This incompressible liquids are there. No, this incompressible liquids are transmitted equally in all direction. Okay, it transmitted equally in all direction. This only Pascal's law. See, when we are giving external pressure to the incompressible liquid, we are giving external pressure to the incompressible liquid, it transmitted equally in all direction. It transmitted equally in all direction. So, Pascal's law. So, Pascal's law, external force applied in the incompressible liquid, it transmits equally in all direction. So, these are about the Pascal's law. Who demonstrated this Pascal's law? Blaise Pascal. So, the law is called Pascal's law. What is Pascal's law? So, Pascal's law demonstrated by using a glass jar. Inside the glass jar, what is there? Liquid is there. Incompressible liquid. No, liquid is there. So, when we are giving external pressure, here piston, we are using piston. No, by using the piston, external pressure, if you give this glass vessel, what happened? The incompressible liquid are equally transmitted in all direction. In all direction, equally transmitted. Same pressure, all the liquid will come out. So, this is the Pascal's law. Can you understand about Pascal's law? Now, state Pascal's law. Important question, state Pascal's law. The external pressure applied in the incompressible liquid, the liquid will transmit equally in all directions. So, Pascal's law, the external pressure applied on the incompressible liquid, the liquid transmitted equally in all directions. So, this is the definition for Pascal's law. Next one, hydraulic press. First we have learned about Pascal's law. Next one, hydraulic press. This hydraulic press used under the principle of Pascal's law. Now just listen the diagram. It consists of, we are using two cylinders. See, but the area of cross section different. So this area of cross section A and the area of cross section small a. So area this larger cylinder, the smaller cylinder. The area of cross section is capital A and small a. Now we are using here piston. We are full of water. Full of water. I told already here which principle used? Pascal's law principle. Now here we are giving external force. External force, that is F1. Here we are applying force, that is F1, through this smallest area cylinder. We are giving external force. Some pressure we are giving. So that is F1. Now what happened when we are giving some external pressure in the cylinder? What happened? The liquids, this incompressible liquids, all the same pressure, it will move upward. No, it will move upward. So this F2, through F2, the pressure will move upwards this piston. Okay. So first the force act in the smallest cylinder, and all the liquid with the same pressure it will push upwards. So we have see the pressure. So suppose here pressure P1. P1. What is the formula for pressure? Already we have learned. What is the formula for pressure? Force divided by area. Two formulas there. No, here we are applying force and area of cross section we are using. So we have to use this formula P equal to F divided by A. Suppose the pressure P1 means what is the force? F1, and the area of cross section we can take as A1. Okay, so P1 equal to F1 divided by A1. So this equation, take equation number 1. Equation number 1, P1 equal to F1 divided by A1. What is P1? Pressure, the smallest area cylinder pressure, and F1 also force applied on the smallest cylinder. A1 area of cross section of the smallest cylinder. The next, the force applied here, and the external force we are applying in the incompressible liquid. What happened? It flows equally in all direction. No, this is now the direction, upward direction, that is F2. So the pressure P2 equal to, say here, F2 divided by A2. What is F2? The force in the larger cylinder. A2, the area of cross section of the larger cylinder. P2, the pressure occurs in the larger cylinder. So this equation number 2. So first equation, P1 equal to F1 divided by A1. P2 equal to F2 divided by A2. The second equation. Now we can compare these two equations. So that is P1 equal to P2. In same direction. No, it will cross same direction. So P1 equal to P2. Now we can write here F1 divided by A1 equal to F2 divided by A2. We can write here equal to P1 equal to P1 F1 divided by A1, P2 F2 divided by A2. From this we can find here F2 value. F2 means what? The F2, the force applied on the largest cylinder. So F2 we have to calculate. So just cross multiply 2 also. So F2 A1 equal to F1 A2. From here F2, that means F2 equal to F1 A2 divided by. So this is the formula for force act on the largest cylinder. The formula is F2 equal to F1 A2 divided by F1 into A2 divided by A1. What is F2? The force act on the largest cylinder. F1, the force act on the smallest cylinder. A2, area of cross section largest cylinder. A1, area of cross section of the smallest cylinder. So this is about the hydraulic press. So by using this formula, problem number 4, example problem given by using this formula. They are given force applied. No, first force we are giving that given, and A2 and A1 area of cross section also given. Just you have to multiply. So there in that problem weight given. So mass given in kilogram given, that is mass. So we have to find F. So what is the formula for force? F equal to ma. Problem number 4. This one, example problem number 4. So F equal to ma. Already you know this formula. F equal to ma. Or weight formula you know, W equal to mg. Like that formula also you know. So the mass given in the question, suppose a 1000, mass 1000 given, into acceleration due to gravity we have to multiply. So that is 9.8. 9.8 you have to multiply, then substitute the value A2 and A1, then multiply and divide and write, you will get the answer. Okay, the problem number, example problem number 4. So what is given? The mass only given, you have to find force, or weight you have to find by using that formula. So the mass into, you have to multiply 9.8. What is 9.8? Which value? Acceleration due to gravity of the earth value 9.8. You have to multiply this 9.8 and the value given, area of cross section A2 and A1 given. So just you have to multiply and divide, you get the answer. So now force only you have to find. Now what is the unit of force? Newton is the unit of force. Then you have to write the unit. What is the unit? Newton is the unit of force. Next we can see relative density. So what is the unit of relative density? There is no unit for relative density. What's the unit of relative density? There is no unit for relative density. See, relative density means just a comparison of density of a substance to the density of water. Okay, we can compare density of substance and the density of water. So what is the suppose mercury? What is the density of mercury? 13,600. And water, what's the density of water? 1000 kilogram meter power minus 3. So this 2 unit also, kilogram meter power minus 3. So just we can compare by using this relative density. Okay, relative density means the ratio of the density of a substance to the density of water. So what's the formula for relative density? Relative or density D. Relative density equal to the density of the substance divided by density of water. The formula for relative density is the density of a substance divided by density of water. What is the unit of relative density? There is no relative density. Now we can study the definition for relative density. Relative density is defined as the ratio of, so here you have to write a ratio of density of a substance to the density of water. So the relative density is defined as the ratio of density of a substance to the density of water. What is the unit of relative density? There is no unit for relative density. No unit. What is the unit for relative density? No. Now we have learned the formula for relative density and unit and definition also. So what is the formula? Relative density equal to density of a substance divided by density of water. The unit of relative density is no unit. What is the definition for relative density? The ratio of density of a substance to the density of water. Now density formula already you have know. So density equal to mass divided by volume. This formula already lower class you have learned. Density equal to mass divided by volume. So we have to write here density of a substance, mass of a substance divided by volume of a substance. So instead of that we can write mass of a substance divided by volume of a substance. Then here density of water, mass of a water, mass of water divided by volume of water. So we can write by using this formula Instead of density, mass divided by volume. So density of a substance, mass of a substance divided by volume of a substance. The density of water, mass of water divided by volume of water. Now, volume of a substance is equal to volume of water. Volume same. So, volume of a substance divided by volume of water. Next step we can write the mass of a substance divided by mass of water. Okay. Mass of a certain volume of a substance divided by mass of water. Mass of a certain volume of substance divided by mass of a water. So, we can write this formula for relative density. Density of a substance divided by density of water. So the formula for relative density, density of a substance divided by density of water. By using this formula, we have to do problem. So your exercise problem is there. After this lesson, we can do that problem. Now relative density equal to density of a substance divided by density of water. Just they are given density of substance value given in the question, and density of water is 1000. Just to divide, you will get the answer. So what unit you have to write for relative density? No need to write any unit because relative density has no unit. Floating and sinking. You all know some objects will float on a water and some objects will sink on a water. So what is the reason? Do you know why some objects are floating or why some objects are sinking? Do you know the reason? Suppose we are taking a cup of water. A leaf fall on the water. What happened? A leaf fall on the water. What happened? It will float. Now, why this leaf is floating? Do you know the reason why the leaf is floating? Because this density of a substance is less than the density of water. So, the object is floating. Why the object is floating? The density of the object is less than the density of water. So, the object is floating. Sometimes the iron nail falls on the water, liquid. So, what happens? It will sink. So, what is the reason? The density of the object is greater than the density of water. So, the object is sink. Now, you know the reason for floating and sinking. So, why the object is floating? The density of a substance is less than the density of water. So, the object is floating. Now, the density of object is greater than the density of water. So, the object is sink. So, because of this reason, some objects are float on the water, some objects are sink on the water. Okay. Now, Rome letter 8, question number 2. The question is, density of mercury is 13,600 kilogram meter power minus 3. Calculate the relative density. So, what is given? Density of a substance given. Which substance given? Mercury. Now, so first you have to write given density of mercury. Equal to 13,600 kilogram meter power minus 3. Now, density of water. Question not given. So, you have to write the density of water. Density of water. What's the density of water? 1000 kilogram meter power minus 3. Now, you have to find the relative density. What's the formula for relative density? Relative density equal to density of substance. Instead of substance, you have to write this mercury. So, density of mercury divided by density of water. Now, what is the value of density of mercury? 13,600 divided by 1000. So, just you can cancel and we can write here 1.36. So, unit want to write? There is no unit. Relative density has no unit, so no need to write unit. So, this is the answer. First see, the density of mercury is given in the question. Density of water not given in the question. You have to write the density of water value 1000 kilogram meter power minus 3. Calculate the relative density. Like this only question given. So you have to write first given, then formula, substitution, answer with the unit. But here relative density has no unit, so no need to write it. This question number from letter 8, question number 2. So this is the question, this is the answer. Just to notice this answer. Density of mercury equal to 13,600 kilogram meter power minus 3. The density of water equal to 1000 kilogram meter power minus 3. The relative density formula you have to write. Then substitute the value and write the answer. Okay students, now take a book all of you. Now we can mark the question. Numerical problem, Rome letter 8, third question. Second question already you have written. Third question, the density of water is 1 gram centimeter power minus 3. What is the density in SI unit? The answer is 1000 kilogram meter power minus 3. Here given 1 gram centimeter power minus 3. You have to write in SI unit. So, gram you have to write kilogram. Centimeter you have to write meter. So, the answer is 1000 kilogram meter power minus 3. Next, Rome letter 6, question number 3. How does an object density determine whether the object will sink or float in water? Page number 32, floating and sinking. Under this heading, just to mark it. Rome letter 6, question number 3, that paragraph fully. Yes. Rome letter 5, fifth question, state Pascal's law. Page number 31, third line. The external pressure applied on an incompressible liquid is transmitted uniformly throughout the liquid. Today 2 questions you have marked. That 2 question also write as assignment. All of you know Rome letter 5 fifth question and Rome letter 6 third question assignment. Next day assignment only 2 questions, states Pascal's law and Rome letter 6 third question.